All right, you are welcome again. Today, let's take a look at Laplace transform. And under Laplace transform, let's see how we can find the Laplace transform of f of t equal to sine squared at, and number 2, f of t is equal to cos squared at. All right, please pay attention. Now, normally I can just go ahead and solve this using trigonometric identities, okay? But a lot of people will ask, how did you get this trigonometry? How did you get this? How did you get it? So because of those questions, I want us to start from the beginning, okay? And then down to the trigonometric identity you are going to use, and then we solve this, okay? Now, you understand this trigonometric identity, sine squared a plus cos squared a is equal to 1. Sine squared a plus cos squared a is equal to 1. If you make sine squared a the subject, you are going to have 1 minus cos squared a. And if you make cos squared a the subject, you are going to have 1 minus sine squared a. Understood? Yes. Now let's go again. You remember this trigonometric relation that says cos A plus B is equal to cos A cos B minus sin A sin B. Hello, are you aware of this? Good. Now, what if you have cos A plus A? That means in place of B, we have A now. Okay, we are now replacing B with A, meaning we have cos A cos A. Cos A plus A. Hello, meaning we have what? Cos A plus A. So anywhere we see B, we're going to write A, meaning we're going to have cos A minus sin A. So cos A is cos squared A. Sin A is sin squared A, meaning that cos 2A is equal to cos squared A minus sin squared A. Hello. Now let's go. We said that we have a value for cos squared A and we have a value for sin squared A. We can replace cos squared A with 1 minus sin squared A and then sin squared A with 1 minus cos squared A, right? Good. Now, let's go. Let's replace cos squared A with 1 minus sin squared A. Now, when we do so, we are going to say that cos 2A is equal to 1 minus sin squared A in bracket minus sin squared A. Let's open this bracket. We are going to have 1 minus sin squared A minus sin squared A, which is 1 minus 2 sin squared A. Hello, are we together? Now, we are interested in sin squared A. Let's make sin squared A the subject. Making sin squared A the subject, we are going to take 1 to the other side, which is going to give us negative. That means we have cos 2A minus 1. Now divided by minus 2, which is the coefficient of sin squared A. So when we do so, we are going to have sin squared A is equal to, this minus now, use it to multiply the numerator. We are going to have the place where we have cos squared A is going to give us negative. Where we have cos 2A is going to give us negative, and then the minus 1 will turn to positive. So we are going to have 1 minus cos 2A. Let's factor out 1 all over 2. So we are going to see that sin squared A is equal to 1 all over 2 open bracket 1 minus cos 2A. Hello. Now, we see that sin squared A is equal to 1 all over 2 open bracket 1 minus cos 2A. Now, again, let's go back. Where we have cos 2A is equal to cos squared A minus sin squared A. The one we just solved now, we substituted for sin squared A. Now, let's do same for sin squared A. Okay, we solve for cos squared A. Let's do same for sin squared A. Now, sin squared A is 1 minus cos squared A, right? Now let's write it. You are going to have cos 2a is equal to cos 2a minus, in place of sine square a, now we have 1 minus cos squared a. Let's open the bracket. We're going to have cos squared a. Then when we say minus times minus cos squared a, is going to give us plus cos squared a. Now minus multiplied by 1 is going to give us minus 1. Are we together? Yes. So when we simplify this, we have cos squared a plus cos squared a, meaning it's going to give us 2 cos squared a, then we have minus 1. We are interested in making cos squared a the subject, okay? So that means we're going to take minus 1 to the other side, then we're going to have cos 2a plus 1, then divide by 2. That is making cos squared a the subject, right? We're going to have cos squared a is equal to, factor out 1 all over 2, we have 1 all over 2, open bracket, 1 plus cos 2a. Hello. Good. Now, here we have our function f of t is equal to sine squared at, and f of t is equal to cos squared at. So what we are trying to do is we want to deduce this squared to something simple where we can easily use Laplace to evaluate, okay? That was what we just did now. So here we solved and we say that sine squared a is 1 all over 2 open bracket 1 minus cos 2a. Now, in place of this a now, let's write at, because the function we have is f of t is equal to sine squared at. Now, let a equal to at. In this place where we have sine squared a, we're going to write what? At. That means we're going to have sine squared at is equal to 1 all over 2 open bracket 1 minus cos open bracket 2a. In place of a, we have 2at. Hello. Are we together? Meaning that when you say the Laplace transform of sine squared at is the same thing as saying the Laplace transform of 1 all over 2 open bracket 1 minus cos 2at. Let's bring out 1 all over 2 behind the Laplace. We're going to have 1 all over 2 Laplace transform of 1 minus Laplace transform of cos 2at. Let's evaluate. The Laplace transform of 1 is 1 all over s. And then the Laplace transform of cos 2at is going to give us s all over s squared plus 4a squared. Hello. It's going to give us s all over s squared plus 4a squared. Now let's add these two together, okay? Let's add 1 all over s minus s all over s squared plus 4a squared. Let's add it together. The LCM is going to give us s open bracket s squared plus 4a squared. Now, when we add it together, I think you can do this. You can do this, right? When we add it together, we're going to see that the numerator, we have s squared plus 4a squared minus s squared, right? S squared minus s squared is going to go, right? We have 4a squared in the numerator. So here we have 1 all over 2 open bracket 4a squared all over s open bracket s squared plus 4a squared. Now here we have 1 all over 2 multiplied by. So using this 1 all over 2 to multiply the 4 at the numerator is going to give us 2. So here we have 2a squared all over s open bracket s squared plus 4a squared. Hello. Meaning that the Laplace transform of sine squared at, the Laplace transform of sine squared at is equal to 2a squared all over s open bracket s squared plus 4at. Hello. Now let's go. The second one, f of t equal to cos squared at. Now you remember the trigonometric relation we just did, right? Now I will say that cos a, I will say that cos squared a is equal to 1 all over 2 open bracket to 1 plus cos 2a. Again, let a equal to 80, meaning we are going to have cos squared 80 is equal to 1 all over 2 open bracket 1 plus cos 2at. Hello. Good. Now from here, when we take the Laplace transform on both sides, meaning we say the Laplace transform of cos squared 80, then we're going to have is equal to Laplace transform of 1 all over 2 open bracket 1 plus cos 280. Let's take 1 all over 2 behind the Laplace, okay? Now, when we take it behind, we're going to have 1 all over 2 open bracket Laplace transform of 1 plus Laplace transform of cos 280. Now, Laplace transform of 1 is 1 all over s. Laplace transform of cos 280 is s all over s squared plus 4a squared. Are we together? Let's combine this together. So when we combine it together, we're going to have 1 all over 2 open bracket s squared plus 4a squared plus s squared. That is s times s, right? Good. Now the numerator, let's add up. We're going to have s squared plus s squared is going to give us 2s squared. Then we have plus 4a squared. So here we have 1 all over 2 open bracket 2s squared plus 4a squared. Let's factor out 2 in the numerator. We are going to have 2 open bracket s squared plus 2a squared. Now here we have 1 all over 2 outside multiplied by whatever inside, meaning this 1 all over 2 multiplied by 2 in the numerator is going to cancel, right? So therefore, the Laplace transform of cos squared 80 is equal to s squared plus 2a squared all over s open bracket s squared plus 4a squared. Hello, Laplace transform of cos squared 80 is equal to s squared plus 2a squared all over s open bracket s squared plus 4a squared. Hello. Yes, thank you very much. Please, I want you to go through this lesson again and again until you become very familiar with it. All right. Thank you very much for watching. Please, if you are new to our YouTube channel, please do well to like, share our videos, and also subscribe. Turn on the notification button so that anytime we drop a lesson on mathematics, you'll be able to see it. Okay. Thank you for watching. Stay blessed. Thank you.